doing, man, gonna talk about exam review a little bit. Just give you a little summary of everything that we kind of went through. All right. So again, we should understand and know all this information already, but again, just want to make sure I refresh you before the exam next week. All right. So again, the air around you, like what is the air around you? What are we breathing in? All right. So again, we should understand that the number one, the most abundant is, you said before me, yes, nitrogen. And then we have 78%. We have oxygen at 21%, and then we have trace gases at 1%. Within the trace gases, are they important? Yes, they are. All right. So again, carbon, argon, water vapors, particles, all of that stuff is going to work together to make sure that you yourself survives. All right. So again, but on the test form, make sure you understand the two most abundant ones, nitrogen and oxygen. It may ask you a question on the reverse. What other than the two most important ones, what other stuff? You'd be like trace gases. All right. Something real simple. What we did next was explain that air existed. So we blew up a balloon that showed it took up space, and then we put it on the triple beam balance. And once we put that on the triple beam balance, we determined that it also had mass, and because it has mass, it also has density and pressure, which are properties of air. That is important because when we get into talking about winds and things like that, we need there to be a pressure. Difference. All right. So we talked about having a column of pressure on you that's heavier than a bus, and we said, well, it doesn't crush you because it's pushing on you from every direction, because again, we want to make sure everything is balanced out. And if it's balanced out, then we're good. If it's not balanced out, we'll get storms and different things like that. And then after the storm comes the calm, because the atmosphere is kind of balancing itself out. All right. So again, density, pressure. How do you determine pressure? With a barometer. All right. So again, that's just an instrument you use. You just need to know the definition of that. All right. Next, we talked about the layers. All right. You need to understand the layers from bottom to top, from top to bottom. Typically on tests, we're going to give it to you in a way that says, what's the first layer? You say the troposphere. What's the second layer? You say the stratosphere. What's the third? The mesosphere. The fourth is the thermosphere. If we was doing 5, you would say the exosphere, but thermosphere is split into 2. If we said go from top to bottom, you go thermosphere all the way down to the troposphere. You need to understand the differences in density and the differences in pressure, because as you go up, pressure goes down. As you go up, density goes down. So if I start with stratosphere and I say, you know what, I want you to count from bottom to top, starting from the stratosphere in terms of more pressure to less pressure. So you go from stratosphere, mesosphere to thermosphere. If I said it in reverse, again, you would come to reverse, and then air pressure will be, the same way. All right. So if I ask you to compare the densities from the thermosphere and the mesosphere, you can either say the thermosphere has less pressure, or you can say the mesosphere has more pressure, more density. All right. So again, as you go down, it gets more dense. The most dense layer that we have is the troposphere. So that's where we live. That's why we can have weather, and that's why we can have all of this stuff. All right. Now, and I know a lot of people miss this, and I think it's probably a little more on me than it is on you. As you go up, there's no line in the sky that says, hey man, you passed the line, we're now in the stratosphere. Oh, there's another line. We just know because the temperature changes. So again, how do we know the difference between the layers? Because of the temperature change. All right. So on the test, when I know you said we talked about altitude and then going up, and this layer being from 0 to 12 kilometers, and the next one being from 12 to 15, and the next one being from 50 to 80, and the next one being from 80 on out. All right. Now it's good to understand and know that information, but understand the reason that we got the kilometers on that is because the temperature will change at that. So again, it's a zigzag. So from the troposphere All right, going up is going to get colder. So when you get to the top of the mountain, it's going to have snow. And at the bottom of the mountain, you probably won't have any. So again, you going up, it's colder. The stratosphere is going to get warmer. You have the ozone layer, you have UV light, and then again, it's going to reverse again. All right, so again, it's zigzag. So it goes from warm to cold, cold to warm, warm to cold, cold to warm. All right. So again, in terms of increase and in decreasing, understand what each layer is known for: troposphere, weather, stratosphere, the ozone, protect you from UV light. A mesosphere, meteoroids. All right. You think meteoroids, think re-entry. It burns up. Now, if something is big enough to get through that, then it's going to impact Earth. Then as you go up, then there's the thermosphere, which is the hottest layer, but you don't feel it because it's not as dense. It doesn't have a lot of those particles bumping around to bump into you to warm you up. So therefore, it wouldn't feel hot, but it is the hottest layer because the sun energy hits it first. All right. Now, talking about the sun's energy. All right. The sun energy has to get through Earth, and once the sun energy gets to Earth, obviously electromagnetic waves, and it has to come to Earth. And once it gets here, it has to interact with our atmosphere. So first, it's going to go through the layers, all right? So the sun has energy on like spectrum from like microwaves to gamma rays. We talked about gamma rays, the Hulk, Spider-Man, they get real strong, and Hulk smash, and they crash and they smash and stuff. In real life, probably not going to survive, probably going to destroy your cells, and then I'll see you on the other side, all right? And I'll tell you, hey, when I get there. Now, what's good about us is, and I call them the air Avengers, the layers of the air Avengers, they're going to protect us. They're going to protect us from the gamma rays. They're going to protect us from the X-rays, the UV, most of the UV light, and all of that stuff, all right? So again, the sun's energy has to interact with the layers, and eventually, once it gets through the layers, and the part that does is mostly visible light, have a little bit of infrared, it's gonna heat up the Earth's surface, which means the surface is, we have water and we have land. We did a experiment and understand that water takes a lot of time to heat up, and land not so much. It can fluctuate, a lot. So again, when that sun energy comes to Earth, it's going to be transferred in 3 different ways. We're going to have radiation. This is stuff we should know, all right? Number 2, said before I said, you can have conduction and you can have convection, all right? So radiation is going to be it's going to be energy directly from the sun, all right? So any of those spectrums, visible light, infrared, all of that's going to be radiation. You can feel it when you're sitting at the beach, slapping you in the face, all right? But what the sun's energy is doing is really going to the Earth to heat the Earth up, all right? So when it heats the Earth itself is going to reach up to the air above it and touch it and heat it up. So that stuff that's feeling on your feet, the sand is really hot, there's going to be conduction, all right? Heat transfer by way of touch. So it's going to reach up and touch that. But it's not going to go up as far. So since it's not going up as far, what's going to happen is that when it heats it, it's going to become less dense, what we talked about earlier, and then that heat is going to rise. And when that heat rises, all right, it's going to cool down, because in the troposphere, what happens is as you go up higher, you're going to cool. As you go up in altitude, you're going to cool down. And once you cool down, all right, eventually you'll get heavy enough to fall back to the Earth, and that's going to get that whole convection cycle, all right? So you have cool going, warming up, then it gets cool, then it's going to drop back down, it's going to replace it, and you're going to get this whole cycle going. Water cycle, weather, everything. When you talk weather, you're really just talking convection. But yes, do you need radiation? Do you need the conduction? All of that stuff works together. But when we're talking about weather, when we're talking about wind, everything we're talking about, you're going to be talking about convection, all right? So again, those are 3 heat transfers: radiation, all right? Convection, conduction, all right? So again, on the test, conduction, is somebody gonna say you touch a pot, your hand is hot, it's conduction, all right? Just for an example. But I want you to understand that how it works in the system of the weather, all right? So convection, again, is gonna have this whole thing. It's gonna have hot going up, cold coming in to replace it, and then you're gonna have radiation. It's gonna always normally be dealing with the sun, or you can get it at a fireplace when you can feel the heat coming off. Please don't put your hand in there, that would be conduction. All right? Now, greenhouse effect. It's important. Essentially, we're gonna trap air. We got greenhouse gases, carbon, methane, but again, it's to make the earth suitable for us to live. All right? So that's why the whole global warming and the other things about stripping away the ozone, because again, it would make it less suitable if the layers were swept away and we couldn't, we couldn't protect ourselves from really, really cold weather. So again, it's going to keep it hospitable for us to live. All right. So we're just keeping it at a certain temperature. All right. Now, once we get into the sun's energy, and the sun's energy is going to heat the earth, it's going to heat it in a particular way. And it's going to heat it in a particular way because the earth is a big round ball sitting in the sky just floating. If you don't believe in magic, you should, because it is amazing to even think about that I can stand on something, but then it be floating on something else. That is science. Purely amazing. But anyway, a ball in the sky, the sun is going to hit it, not all the same because we're not flat and we're not like a pan of pizza, and it's not going to just hit us. So again, it's going to hit the equator more directly, all right? That's why it's normally really warm, really hot at the equator, and it's going to hit the poles indirectly. So that's why it's going to be cold at the north and the south pole. So it's going to be colder at those two. It's going to be warmer in the middle. And net pressure, that difference in heating is going to create a pressure difference, which is going to create wind. That wind is going to be affected also by the earth itself spinning. That's called the Coriolis effect. It's going to cause the winds to turn in a particular way. When we talk about winds, uneven heating of Earth's surface, all right, from local to global winds, they're the same. So I say it again, uneven heating of the surface. And because it's heated unevenly, that is going to cause that warm air to rise up. It's going to cause it to be less dense. That cool air, which is more dense, is going to swoop in. Again, that's when you're going to get your wind, all right? So again, local winds, sea breeze, land breeze, understand the difference. If it's a sea breeze, all right, winds are determined by the direction that they come from. It's going to come from the sea. Well, why does it come from the sea? It's coming from the sea because the land is warmer this time. And because the land is warmer, is going to create a less dense area, and that more dense air is going to rush in. It's going to slap you in the face, and you're going to be like, thank goodness it was hot outside, but I'm getting this cool breeze off of the beach. This is wonderful. But again, at nighttime, you're going to get the reverse. It's going to change. Now, why is it changing? It's really changing because the land itself is going to cool down. We did the experiment. We know land is going to cool down. It's going to fluctuate. So when the land cools down, the water is going to essentially stay the same, and the breeze is going to reverse. So a land breeze is going to go from land to sea. All right? So understand that in terms of global winds. It's going to happen the same way. It's uneven heating, but it's winds over a longer distance. So we have trade winds, we have prevailing westerlies, and we have polar easterlies starting at the poles, okay? This is stuff we should know. Understand which directions that they blow. Prevailing westerlies is in the name, west to east. Jet stream is also in there because this is dealing with us, all right? From west to east. The polar easterlies go from east to west, and then the trade winds go from east to west. Now, in between those, we have the doldrums, we have harsh latitude. Y'all remember they threw the horses overboard because there was a place in the middle where there was just no wind. No wind, no food, horses had to go. Hope you can swim or be like the one on Frozen that had wings and ran through water and turned into ice and did all that. But I doubt it, all right? So again, we have the winds, the Coriolis effect, all right? So when we talked about the winds, we got into talking about the water cycle, all right? So when you have winds, all right? So again, what drives it? The sun heats it up, heats the earth up, all right? We sweat, plants sweat, you got transpiration, you got the ocean, a lot of water, you got evaporation. When that water goes up, it's gonna cool down. And then when it reaches dew point, eventually it's gonna condense or go through condensation. Condensation is the formation of clouds. Why is that important? Because we need the clouds to rain down fresh water, because we can't go to the ocean and just stick our head in the water and drink that salt water. Would not be good for you. But the sun can do it. It giveth, all right? Rains back down, all right? Again, precipitation. It's going to feed the plants, it's going to feed us, and then we'll get rid of it, and then it'll run back to the ocean, and then it'll do it all again. Perfect, because we need it. Because if we didn't have water, well, we wouldn't be able to do this video right now, all right? Now, we talked about different clouds, cumulus clouds, cumulonimbus clouds. Different cloud types signal different types of weather, because we're going in the direction of predicting the weather, all right? The most noticeable clouds is probably, I'd say, stratus and cumulonimbus. Stratus, gray, cover the sky, normally accompanied with a warm front. Then we have cumulonimbus, thunderclouds, normally accompanied with a cold front. There's going to be abrupt weather change. With the cumulonimbus clouds, you can get the tornadoes, the thunderstorms. Probably going to get hurricanes with a low pressure system. So all of that is going to go together, all right, and in helping us predicting the weather. Now, we also talked about air masses. You know, where do they form? They form over land, so it's going to be dry. If it formed over cold land, it's going to be dry and cold, which is going to be continental polar, all right? If it's formed over water, it's going to be maritime. If it's formed over cold water, it's going to be maritime polar. If it forms over warm, it's going to be tropical. If it's formed over land, it's going to be continental, so it'll be continental tropical. If it's water, it's maritime tropical. Why is that important? Because wherever it develops over is the characteristics of it. So if it forms over water, it has water. Who needs water? You do. I do. We do. Your dog does. Your baby dog probably doesn't. But everything else that lives, breathes, eats, whatever, we need water to survive. So that's very important to understand the different air masses, all right? Now, what is an air mass? A lot of people miss this. Like when it meets the land, no. Air meets air. When it hits each other, it's a front, all right? Now, there's two fronts still there. It's going to be a warm and a cold. If the cold wins, it's a cold front. If the warm wins, it's a cold front. If they're stationary, if they don't win, it's stationary. And if they block, if it's too cold and the warm blocking the warm from the ground, it's an occluded front, really special front. Doesn't happen all the time, okay? So again, if they hit each other, if they're telling you that this front is winning, then that's the front that is called. And different fronts are gonna bring different weather. Cold fronts, more severe, heavier rain. It's gonna be a little more abrupt, quick. All right, warm front, several days of rain. It's gonna catch up from behind and moves a little bit slow, so the clouds are gonna be spread out. So understand all of this stuff, all right? Now, when we get through the air mass and we get the fronts, again, definitions. Isobars connect things of pressure, bars on you, pressure. Isotherm, thermometer, connect places of particular temperature, all right? So again, we get to predict the weather. That's all this is about. It's a weather unit. We're talking about predicting the weather. Why is it important to predict the weather? Because you don't want to end up like Dorothy in Kansas, inside of a tornado, laying on the bed, looking out the window at other people in the tornado riding bikes and different things like that, and cows who was not prepared for it. So again, weather is very important, because you can hear the sirens go off. Well, you know what? It's time to go into the basement, or it's a hurricane, it's time to evacuate, or it's a thunderstorm, probably shouldn't get in the shower, probably should cut the lights off. So it's very, very important to be able to predict the weather, because of it can be something as simple as, I probably shouldn't plan my birthday this weekend, or something as severe as, you know what? Probably should get out of this house or get to somewhere with shelter, because it could be deadly consequences if I do not move right now. All right. So again, the exam is on Monday, and then some people got it on Tuesday, some got it on Wednesday, some have it on Thursday. Good luck. You will do fine. Just make sure you understand this stuff. Make sure you understand the concept, the heating and the cooling. All right. Warm air is less dense, cool air is more dense. And if you can explain those two things and explain how wind is created, you got this in the bag, all right? Good luck and have a Merry Christmas, all right?